Hello, welcome to another Clojure diary video. So in this video we are going to see how to find Pythagorean triplets. That is from you just give any two numbers and between those two numbers if they are Pythagorean triplets it's going to find. So that's how it is. So let me just show you how it works. So if I just put like find pi triplets, right? And if I just say like from 1 to 20 find all pi triplets. So it just finds out. So yeah, let's see how it works. I'm not sure whether this program is efficient or not, but yeah, let's see how it works. Right? So here is this function. Okay, find pi triplets, right? So this has been called, and we are just giving a start and end over here. Right? So that's how it is, and it just somehow magically finds pi triplets. Okay, so in this, like, we just have a thing called numbers, and over here it's like range, start and end and all those things. So let me just try it out with, okay, like this one. Start is like what, 1, and end is 20, right? So what this does, so this essentially what it does is it puts all the numbers from 1 to 20, right? That's how it is. Okay, and now there is a thing called num combinations. Okay, so there is this, okay, or number combinations, this function over here, right? So this function is there, right? And so this numbers is, yeah, range is like a Clojure function, so it's kind of self-explanatory. So, and now if I just put this over here, like this number combinations, right? What happens is you get all combinations. Okay, so I think even there is 1, 2, 3 somewhere, or I'm not sure, but yeah, it just gives all combinations. But yeah, just to explain, yeah, let me just put it as a very small number so that like you people can understand. So yeah, it gives all possible combinations. Okay, from like from 1 to 3. Okay, and I don't think there are any unique combinations. Okay, so and is there 1, 2, 3? Yeah, 1, 2, 3 is there. Yeah. So yeah, I just got it out. Okay, so it just gives all unique combinations between the start and the end numbers. Okay, so that's the thing. So how this works? Okay, so this number combinations is there, right? Okay, so you just have this for x, y, z, and what to say, like uh, okay, x in nums. Okay, so you just get this numbers over here. So x in nums means x will become like 1 to 3, and similarly y will also become 1 to 3, and z will also become 1 to 3. So, and what it is doing is you're just building a list. Like, okay, like the list is like 1, x is 1, y is 1, z is 1, means it's 1, 1, 1. And now, like, I think x is 1, y is 1, and z is 2. So it will become more like 1, 1, 2, and so on and so forth. And then finally you're just sorting it. I'm not sure why we are sorting it. Okay, but yeah, anyway, we are just sorting it. Okay, right? And then we're just taking a set so that it will just become unique. Okay, so this will just give the number combinations, and it will just give the unique one. Okay, so it's not permutations, it's combinations. Okay, so combinations means it's unique and all those stuff. Okay, so that's the thing. So this one gives all unique combinations. So all we just need to do is, like, we just need to find out, like, okay, like let's say like this 3 square is equal to 1 square plus 1 square. Of course it's not, but yeah, like let me just put something like I'm sorry, so let me put something like, okay, this thing, like, okay, so this will definitely put 3, 4, 5 somewhere. Okay, so where is this 3, 4, 5? Okay, so it's not sorted. Yeah, 3, 4, 5 is there. So all you just need to check is like whether this highest number, like where did it go? Oops. Okay, so I think I just lost it somewhere. Okay, so let's say like we just have like 3, 4, 5. So all we just need to do is to check whether this 5 square is equal to 3 square or 4 square, or the largest number square is equal to the square of next two numbers. So actually, yeah, so that's what we're just doing. So what we're just doing is like we are just putting something called triplets. Okay, so and then over here we are just putting like filter triplets. So what this filter triplets does is let us just go here. So you just have a filter over here. This filter checks whether something is Pythagorean triplets or not. Okay, so and it just takes the first argument, and nth means, yeah, like nth of the argument, one means second, and the last means the third. Okay, so it just takes three arguments and checks whether it's Pythagorean triplets or not. To this we are just passing this number combination. So what this Pythagorean triplet does is, so all it just does is it takes ABC and yeah, it just sorts ABC. So and puts it into XYZ. So the Z will have the highest number, right? Okay, so the Z will have the highest number, and it just checks whether the square of Z is equal to the square of X, and summation of square of X is the summation of square of X and Y. So that's what it just checks. So it just checks whether the highest number is equal, the square of the highest number is equal to the square of other two numbers. So that's what it just checks. If it's equal to, yeah, it returns true, otherwise it returns false. And I've just defined square over here. You could say, like, you could put like, okay, star XX, star YY. But yeah, I just thought, okay, let it be more readable and something like that. So I just put square over here. So, and I haven't even written a documentation for the square because I just thought it's very, very obvious, right? So that's how it is. So if both are equal to, it returns true, otherwise it's false. Okay, so what this filter does is, like, so whenever it's true, okay, so yeah, whenever it's true, it just takes those combinations. So for over here, like if you just put like, okay, like find pi triplets. So, and if I just give like 1 and 5, I am just only getting 3, 4, 5. So in all this numbers, okay, all this numbers, what it just does is, whichever is true. So for only for 3, 4, 5, it will be true. Okay, so it just takes and it just collects it, and that's how it's just a filter. Okay, it's a Clojure function, and it's just a filter. It just collects it, and it's just been stored in this triplets. Okay, and once again I'm just sorting it, right? I'm just sorting it by the first one. Okay, so the first number, and so that, like, it'll be, you just get something like a sortable list, and I'm just giving out the triplets. Of course, things will work even if you don't put this sort by and all this stuff. So it will still work. So that's how it is, and so you just get the output. So if you're following this blog and if you know Clojure, okay, this might make sense. But for other people, it might look like, come on, like, how did they do it and all this stuff. Right? But yeah, so this is how it is, and this is how Clojure works. So all I'm just doing is, like, okay, getting all numbers from the start to end. I'm just doing the combinations over here, and what to say, like, I'm just filtering out the Pythagorean triplets over here. Okay, so I'm just assigning it to a variable called triplets, and finally I'm just sorting by the first number of triplets, and I'm just returning, and you just get it. So yeah, here is it. Like, just put it from 1 to 50. Yeah, so let me just put, like, okay, like, there are something from 10 to 50 or something like that. And yeah, there are some numbers like 10 to 50. There are some numbers Pythagorean triplets. Okay, yeah, right. What about like 40 to 50? I don't think so. Yeah, right. And yeah, like, I even tested for higher numbers, but maybe I think when it goes till 1000, things are just getting really worse, because this combinations will put nearly like 1 billion. Of course, like, we are just only taking the unique one, like, but yeah, it kind of generates 1 million points, and then it just takes the unique one, and it's just kind of a mess over here, right? So that's how it is, and I just remember why I put sort over here. So let's say, like, there are lists, like, okay, like, two lists, like 1, 2, 2, and okay, this is a list. Okay, and there is another list like 2, 1, 2, right? So yeah, and another list like 2, 2, 1. Okay, so if I just want to take something like a unique thing or set or something like that, okay, so okay, yeah, let me just put this into a set, and then if I just put like, okay, like, okay, let me just reduce it. Okay, let me just tell it in simple. Okay, 1 2, and there is another list called uh, okay, 2 1. Okay, so okay, so I think I just need to put something like a list of list. Come on, what happened? Why it isn't working? Yes, okay. Wait. So okay, just let me just put it like a vector. So there is a vector of vectors, and so there is a vector of vectors. So 1 2 and 2 1, right? And come on. God, what happened to me? Yeah. Okay, so now you just take set of it. So you just take the set of it. Okay. So you get 2 1 and 1 2. Okay, you can't look, even though they are of the same combination. So you and your friend is equal to your friend n, no matter whatever order you are arranged. Okay, so that's the thing. So, but now it just gives two combinations. But what if I just pass this to sort? Okay, so I'm just passing this to sort. Okay. So now I'm just passing this to sort. So this 2 1 will also become like 1 2. So now I'm just getting only 1 2. So now I'm just getting only the combination, not the permutations. Okay. So that's why I just put it over here, so that you just get the unique ones. Like, so say if you just give like pi triplets from 1 to 1000, so it's a huge number, right? But of course, a billion stuff will be generated, right? So billion stuff will be generated over here. But then when I just take the set, you'll only get the combinations. So that's why I'm just giving it over here. But yeah, if you just put it from 1 to 1000, it almost nearly crashes. So that's the thing. And yeah, so this is how it is. You just generate all numbers, generate the combination, and you just filter by the triplets and set it out. So that's how simple finding out Pythagorean triplets in Clojure is. I hope you watched this video, possibly understood it or enjoyed it. Anyway, thanks for watching.